Every electric car on the road today, whether it's a Tesla in California, a BMW in Munich, or a BYD in Shenzhen, runs on a battery. And almost every battery on Earth passes through two companies you need to know, CATL and BYD. Together, they control over 55% of the entire global EV battery market. But market share is only the tip of the iceberg. What makes these two companies truly extraordinary and truly dangerous to competitors is that they don't just make batteries. They control the mines that dig up the raw materials, the refineries that process them, the factories that assemble cells, and now even the recycling plants that recover metals from dead batteries. This is the story of the most vertically integrated industrial empire since Standard Oil. Except this time, it doesn't run on petroleum. It runs on lithium, cobalt, nickel, and graphite. The first rule of the battery game is simple. If you don't control the raw materials, someone else controls your future. China understood this before anyone else. Today, Chinese companies control 72% of the cobalt and copper mines in the DRC, a country that produces over 70% of the world's cobalt. Chinese state-owned enterprises control 80% of the output, and Chinese refineries process 67% of the world's refined cobalt. But cobalt is only one piece. Chinese entities now control approximately 60 to 70% of global lithium refining capacity. China produces 77% of the world's natural graphite and processes 95% of the spherical graphite for anodes. The single heaviest component in every EV battery, CATL has committed $6 billion to projects in Indonesia. Mining, processing, and cell manufacturing all on one island. It invested $3.6 billion for a stake in the Congo, $1.4 billion with Argentina's YPF for lithium, $1 billion in Bolivia, and $2 billion across China's Xinjiang. BYD took a slightly different path, securing lithium mines in Brazil's Lithium Valley, across Africa and South America. When Western automakers were still negotiating supply contracts, CATL and BYD were buying the mines themselves. Here's the part most people miss. Mining is important, but it's refining that gives you real power. Australia mines more lithium than China. The Congo mines more cobalt. But almost all of it gets shipped to China to be turned into battery-grade chemicals. China refines roughly 70% of the world's lithium carbonate and lithium hydroxide. It processes around 60% of global lithium, 60–90% of cobalt, and over 90% of both graphite and rare earth elements. Think of it this way. Even if you own a lithium mine in Chile or a cobalt mine in Congo, you still need China to turn that raw rock into something a battery can use. That's the choke point, and it's getting tighter. In December 2023, Beijing imposed export license requirements on graphite, the material that makes up 95% of battery anodes. Then in July 2025, China imposed new export controls on battery cathode production technology and lithium extraction and processing technology. This isn't just industrial policy anymore. It's supply chain weaponization. Now we move to the middle of the supply chain, the part where refined chemicals become actual battery components. And if you thought China's grip was tight at the mining and refining stages, wait until you see the midstream. China produces 70% of the world's cathodes, 85% of its anodes, 74% of separators, and 82% of electrolytes. Even more strikingly, Chinese companies supply between 90% and 97% of the active materials that go into those cathodes and anodes. The separator, a thin membrane that prevents a battery's cathode and anode from short-circuiting, was the last key component China localized. For years, the technology was locked up by Japanese, Korean, European, and American firms. It was the critical bottleneck holding back China's battery ambitions. Companies like ENGIE eventually broke through, reverse engineering and then improving on foreign technology, until China became the world's largest separator manufacturer. When you add it all up, roughly 80% of the world's lithium-ion battery cells are now made in China. That's not just dominance, that's a near monopoly. If CATL is the battery supplier to the world, BYD is something different, and arguably scarier for competitors. BYD doesn't just make batteries, it makes everything. Think about what a traditional automaker looks like. Toyota buys its batteries from Panasonic. Volkswagen buys from various suppliers. Tesla sources about 80% of its batteries externally. BYD does the opposite. Through its subsidiary network, collectively called FinDreams, it controls the entire chain. Lithium mining, battery cell production through its proprietary Blade battery, power electronics, electric motors, semiconductors through BYD Semiconductor, and final vehicle assembly. It even runs its own recycling operation, FinDreams Battery Recycling, creating a closed loop from mine to car and back again. This vertical integration is BYD's secret weapon. It gives the company a roughly 15% cost advantage over Tesla in EV production, with battery costs as low as approximately $0.055 per watt-hour for its latest models. And BYD isn't keeping this technology to itself. In 2024, it signed an 8-year deal with American auto supplier BorgWarner to manufacture FinDreams Blade battery cells in Europe, the Americas, and Asia-Pacific. BYD holds over 29,000 patents, including nearly 19,000 active ones, covering battery chemistry, fast charging systems, and AI-driven manufacturing. In 2025 alone, BYD filed 538 new patents, a 216% surge from the previous year. When your competitor builds everything in-house, from the lithium mine to the chip on the dashboard, and does it at 15% lower cost, that is a structural advantage that money alone cannot buy. While BYD went deep through vertical integration, CATL went wide, building the most expansive battery manufacturing network the world has ever seen. CATL commands 39.2% of the global EV battery market, more than double its nearest competitor. Inside China, its share is even higher at 43.4%. But the real story is CATL's international expansion. In Germany, it already operates a plant in Thuringia. In Hungary, it's invested $7.3 billion, roughly $8.5 billion, in a megafactory in Debrecen with a target capacity of 100 gigawatt-hours per year and up to 9,000 employees. Production is set to begin in early 2026, and CATL says the initial 40 GW capacity is already fully booked by BMW, Stellantis, and Volkswagen. In Indonesia, CATL broke ground on a $6 billion integrated facility on North Maluku Island, mining nickel, processing it into electrodes, manufacturing battery cells, and recycling waste, all on one site. This is what Henry Ford did a century ago with the River Rouge complex, controlling every step from raw iron ore to a finished Model T rolling off the line. CATL is doing the Ford playbook, but for batteries and on a global scale. Controlling mines and factories would mean nothing if the technology wasn't world-class, and this is where CATL and BYD have pulled ahead of almost everyone. The key innovation both companies championed is lithium iron phosphate, LFP. For years, Western and Korean battery makers bet on nickel-rich NMC chemistries for higher energy density. Chinese companies went the other direction. LFP is cheaper, safer, uses no cobalt or nickel, and lasts longer. The trade-off was lower energy density, a disadvantage China's engineers have been systematically erasing. CATL's Shengxing Plus is the world's first LFP battery to exceed 1,000 kilometers of range on a single charge. With 4C superfast charging and an energy density of 215 Wukuluan, shattering the old ceiling for LFP technology. Its Kiln battery reaches 255 bulk kias for NMC chemistry. BYD's answer is the Blade battery, an LFP cell designed as a flat blade that slots directly into the pack, eliminating traditional modules. This cell-to-pack design reduces material use and simplifies assembly. The Blade Battery 2.0 promises a 40% energy density increase to 160 to 10 Wh with charging rates exceeding 5.5 C. BYD famously demonstrated the original Blade battery's safety with a nail penetration test, driving a steel nail through the cell while it's fully charged. No fire, no explosion. NMC batteries in the same test caught fire almost immediately. Both companies are now converging on the next frontier, solid-state batteries by 2027, with CATL targeting 500 Wh/kg and BYD aiming for 400 Wh/kg. The message to the rest of the world is clear. China isn't just manufacturing batteries at scale. It's inventing the next generation of battery technology, while everyone else is still trying to catch up on the current one. There's a final piece of this supply chain story that most people overlook, and it might be the most important of all. China's EV battery recycling market has already reached $78 billion. By 2030, it's projected to exceed $139 billion, with recovered materials worth over $278 billion. The leader in this space is a company most people have never heard of, BRUNP Recycling, a subsidiary of CATL. BRUNP has helped create more than 80% of China's national lithium battery recycling standards. Its proprietary directional recycling technology achieves recovery rates of 99.6% for nickel, cobalt, and manganese, and 96.5% for lithium. In 2024 alone, BRUNP processed over 120,000 tons of end-of-life batteries and produced 17,100 tons of regenerated lithium salts. As of 2024, China had 156 licensed recycling companies with a combined processing capacity of 423 million tons per year. This is what a truly circular supply chain looks like. Phosphate rock from a mine in Hubei used to make fertilizer for decades is now refined by BRUNP into cathode materials for CATL batteries. Old batteries come back, metals are recovered at near-perfect rates, and they go straight back into new cells. It means China doesn't just control where battery materials come from. It's building a system where eventually it won't even need to mine new materials because it recycles the old ones. So let's put the full picture together. We've walked through mining, refining, components, cell manufacturing, technology, and recycling. At every single stage, China, led by CATL and BYD, dominates. This table is the real story. It's not just that China makes more batteries. It's that China controls the entire stack, from the hole in the ground to the finished cell to the recycled metal that goes back in. And here's what makes it nearly impossible to replicate. This took 20 years of coordinated industrial policy, hundreds of billions in subsidies, strategic mineral acquisitions across 4 continents, and the cultivation of 2 national champion companies that are now among the most innovative battery firms on Earth. And here's what makes it nearly impossible to replicate. This took 20 years of coordinated industrial policy, hundreds of billions in subsidies, strategic mineral acquisitions across 4 continents, and the cultivation of 2 national champion companies that are now among the most innovative battery firms on Earth. For competitors, whether in Japan, Korea, Europe, or America, catching up means replicating not 1 advantage, but 10 simultaneously. Against companies that are still accelerating. Simultaneously, against companies that are still accelerating. The United States currently produces 0% of the world's battery-grade graphite anodes. Europe is building factories, but most of them will be filled with cells from Chinese or Korean companies. Japan leads in solid-state battery patents, but has almost no large-scale cell manufacturing. This is the supply chain moat. It's not a wall, it's an ocean. It's not a wall, it's an ocean. In July 2025, China imposed export controls on battery cathode production technology and lithium extraction and processing technology. Earlier, it had already restricted graphite exports. These moves sent a clear signal. The supply chain isn't just an economic asset, it's a strategic weapon. For the rest of the world, the question is no longer whether China dominates the battery supply chain. It does. The question is, what happens next? Can the West build alternative supply chains fast enough? Can Japan's solid-state bet pay off before China gets there too? Can Europe's mega factories compete when their raw materials still flow through Chinese refineries? These are the questions we'll tackle in the next episodes of this series, starting with how Japan, once the undisputed king of the auto industry, is fighting to survive the electric revolution. If you found this useful, subscribe and hit the bell, because the battery supply chain story is the most important industrial story of the 21st century, and most people still don't know it.